Hello. I guess I am live. Just do let me know quickly if the audio and the videos is good. I can see message of Abhishek Sharma, Saket, Bishal, MS Darshan for sure. No man. Yeah. Oh, for sure. I need. Yep. So without further ado, if everything is nice, okay, we can get started with the problems. First three problems were pretty easy, pretty standard, but still we'll quickly go through them. Then we'll look at the fourth problem, which was actually nice. Like legit, the thinking part was not that hard, but actually implementing that was hard. So Paritosh, hello, MS Darshan, yeah. Hey bro, Aryan, yo, no man, everything good? Cool. Let's quickly start with the first problem itself. Let me quickly go on to the standard tablet mode. I guess it is the first problem, yeah. So basically the first problem was pretty simple, that it just says given maximum sum with exactly k elements. You are having a zero index integer array nums and an integer k. Your task is to perform an operation exactly k times in order to maximize your score. Which means, what's the operation you can perform? You can select an element m from your nums array. Cool. Remove the selected element m from the array. Cool. And then add a new element which is m plus 1 in your array. Increase your score by m, return the maximum score you can achieve after performing the operation. See, it's written, you have to achieve the maximum score. You will add the score by, basically you will increase the score by adding m. So you will always try to choose the maximum m. That's the reason what I will do is, I will try to choose the maximum m for sure, because I want to maximize my score, right? And you also see, as you choose the maximum m, the next time your m will increase only. Which means if I choose m, let's say 5 as maximum, so then in the next operation, it will just increase to m plus 1, which is 6. In the next operation, it will increase to m plus 1, which is 7. So choosing the highest maximum value of the whole entire element, I can start with that m and keep on increasing that, because ultimately I want to maximize my score, and score is nothing but just adding those m's. So initially grabbing the maximum m will actually help me. It was as simple that, okay, we just look at the problem, we see, okay, if it is having maximum m or not. If it is, yes, just grab it. If we just look at the first example, I have these 5 elements. What if the k would have been 1? It would have said, just give me 1. Choose 1 and give me maximum. So you would have for sure grabbed 5. But it is now k3, which means you grabbed 5, you removed 5, you added 6. Now, ultimately, you will try to grab 6 only, because 6 is the maximum and you want the maximum score. So you will grab 6 and you will have now 7. Ultimately, you want the maximum score. Now you will grab 7. So your answer is 5 plus 6 plus 7. Although you can actually go on and adding 5 plus 6 plus 7 and so on and so forth, because constraints were pretty small. But as we for sure know that it is nothing but 5 plus 1, 5 plus 2 and so on and so forth, because ultimately I am just grabbing that m, increasing that m by 1, next time grabbing that m plus 1, increasing that m plus 1 by 1, so it is m plus 2 and so on and so forth, and this m will come k times, so it is nothing but m into k plus 0 plus 1 plus 2 up till k minus 1, which is nothing but, it is m into k, and it is nothing but sum of n numbers. Sum of n numbers is nothing but n into n plus 1 by 2. Here n is k minus 1. That's the reason your sum will be k into k minus 1 by 2, which is k into k minus 1 by 2. See, although I could have completed the same problem by just iterating that, because constraints are pretty small, but just to show you how the sum of n numbers, which is actually a math problem, and it's actually very helpful. You should remember what is the sum of n numbers. Although I did the same problem in O of 1 time, but it's actually just to let you know that it can be very helpful. So make sure that I'm not saying to focus on how to implement that, but just to make sure that, okay, it's a tip that how we can use maths in programming. So yeah, we will just do m into k plus k into k minus 1 by 2, and that is how we'll get the answer. Let's quickly implement that if it is good. Paritosh, Amazashan, Numan, Anirban, Venkatesh, and Amazashan. Cool. If you guys have not liked, please, I can see some viewers, see chat rate, see views. If it will be very helpful if we can reach 20 likes, that will be 25. If you can reach 20, for sure, let's try for 20 now. But yeah, without further ado, let's quickly code that first. Let me just remove that and reset. Cool. So if we just quickly see that, what we will do, as I said, I will just grab the maximum element out of all this entire array, because ultimately I just want to do the simple thing. I just wanted that, okay, how many elements are coming and coming. So I'll just grab that maximum element out of the entire element, that ultimately I have that m with me, and it's a maximum element. So it's nothing but max L. My max L is a maximum element. I'm just grabbing right now the maximum element out of the entire array. When this maximum element is done, I have now this maximum element. Now I can just simply return what? As I told you, m into k, maximum element into k plus what? Sum of those k numbers, 0 plus 1 plus 2 up till k minus 1. And that is how I can get k into k minus 1 by 2. That is how we can get the answer. Let me quickly submit, like it would probably be just submitted, and yeah, that's accepted. So yeah, let's go on to the next problem, and if it is good, you guys are awesome. I cannot see anything. Cool. But yeah, let's see the next problem. What we have is yep, let's quickly go on to the tab, and next problem. It's also pretty easy, I should say. If you go to implementation wise, it just says that without, like, still, if you guys have not liked, then please do the like button. We are actually, like, let's aim for 20 likes, and yeah, let's go on to the next problem. If you guys have anything to say, yeah, Venkatesh, that's completely correct. Find the prefix common arrays of two arrays. Oh, what's the problem? Cool. You are having a 0-index integer array permutations as a and b of length n. Now what happens is, a prefix common array of a and b is c, such that c of I is equal to the count of numbers that are present at or before the index I in both a and b. If it is not understandable, no worries, I will explain with the example itself. But return the prefix common array of a and b, which is nothing but c. Now a sequence of n integers is permutation. Okay, if it has, see, what's a permutation is? Of n integers, permutation is when you have n numbers in any order, but there are n unique numbers in that array from 1 to n itself. That's a permutation. What the problem is saying is that if you have this array a as, let me quickly change the size. If you have array a as 1, 3, 2 and 4, if you have array b as 3, 1, 2 and 4, let's find the array C, which means up till this point right here, if I change, yeah, up till this point right here, any common elements, number of common elements between A and B, is there? No, for sure no. Answer is 0. Now up till this point, any common elements between A and B? Yeah, you can see 1 is common and 3 is common, for sure. 2 elements are common, I'll say 2. Up till this point, how many elements are common between A and B? 1 is common, 3 is common, 2 is also common, for sure. Answer is 3. Up till this point, which means the last point, how many elements are common? For sure all. So yeah, answer is 4. Next example, here A is nothing but 2. Change the color. A is nothing but 2, 3, 1. B is nothing but 3, 1 and 2. We will just grab our C, which is, I'll just say, okay, up till this point, number of elements are common, 2 and 3. both are different. Cool, no worries. Up till this point, no elements which are common. 3 is there, but yeah, 2 is not there in B, 1 is not there in A for sure. Only one element is common. So I'll just say, okay, 1. Now, for the last, up till last, you can see all elements are common for sure. Answer is 3. You saw what happened. At every point of time, firstly, I need to go on my entire array of this A and B parallelly, kind of, because I need to return my entire array output to that particular value, right? So what I need to do is, I just need to grab up till X point, up till ith index. Let's say I'm index I. Up till I index, how many elements are there in both A and B? Which means I'll say, is 1 there? 1 is there. Is 1 here? 1 is here. Is 3 here? 3 is here. Is 3 here? Yeah, 3 is here. 2 here? Yeah, here. 2 here? Yeah, here. If, for example, at this point, I'll ask, is 1 here in A? 1 here? Yeah. So shall I count it? No. Is 2 here? Yeah. Is 2 here in B? No. So I'll not count it. I'll ask, is 3 here in A? Yeah, it is there. Is 3 here in B? Yeah, it is there. So I'll just count 1. Now, Aryan, is it possible that I count all the numbers? If you look at the constraints, you can easily see the length of this entire array A is 50. And array A is a permutation of n numbers. So the numbers itself in the entire array are also 50. Which means from 1 to 50. So I can just go on at every index. I'll just go on at every index and check. Okay, give me the count of, I'll just laptop is working. I have to check how I can bring my screen on the laptop. Lovely, light has come. Yeah, so what we were saying was that I will just go on to my array A, and then what will happen is, okay, it is, sorry, really very sorry. Let's quickly change. So yeah, what we were saying that we had this array A, right? I just keep the count, okay, whatsoever count is for every element so far in both array A and array B. At any point of time, what I will do is, I'll just say, what is the count? Sorry, is A in there in is the element 2 in A at this point of time? Is the element 2 in A? Yeah, it is there. Is the element 2 in B? No, it is not there. So I'll not increase my count. While in the case of 3, I'll just ask, is the count, which means is the 3 is in there? Yeah, it is there. Is the 3 in B? Yeah, it is there. For sure. I will increase my count because I have got the answer. That's what we can do. We can just iterate over both of these array parallelly, keep the count of every element, because count is for sure 1. It's just that to make sure, okay, I have that element or not. If that element count is 1, so I have that element. If the count is 0, I don't have that element. So that's the reason I can just maintain the count to check, okay, if this element is present or not. If it is present, well, good, well done. If it is not, then I don't have to add anything. Same thing we will do. We will just go on and have the count with us. Let's, oh, sorry. Bro, one note is not showing. Sorry. Yeah, just 1 second. Oh, damn God. Lovely day. When the light goes, it just ducks up the entire thing. Please open. Damn. What the? Is it opening now? Shit. what the duck happened to my OneNote that it is so mad at me right now. Bangalore. Oof. No, yeah, OneNote used to open, but I don't know why it is not opening right now. Sorry. Just a quick blunder from my side. I should be able to resolve this, but how? USB tethering is on. Okay, USB tethering is on. Let's try now. Please open. No, it's not. Device file transfer, transferring images, charging, and a lovely day. Sorry. Damn. I just need to see that how I can arrange this. I just can remove this for sure. Use my tablet with the, if you guys can hear. No. The stream is fucked up now, for sure. Again, it came again. Why? Oof, fuck. Again. Plan, no problem. We will wait. No. I don't want you guys to wait. It's the second time light has gone. What has happened? And the worst part is my tablet is not connecting. Worst part about live streams, that if it is done. Can anybody help out? I use SCR-CPY for just transferring my screen, but that is just crashing again and again. Quickly resolving the issue. Oof. What I can do? Maybe I can just no problem. Bhai, that is okay, but it needs to start at least. I should have some option to actually restart it back. Why the fuck it is not restarting? Whew. Damn, anti-malware. Okay, shit. Can I just end the stream right now or something like that? Maybe I can just restart it. Because tablet is not restarting, goddamn. Oh, can we just explain by typing? I guess we can't. Really sorry for what I am doing right now. I'll just USB. Consistent viewer of your channel. Sorry, and USB debugging. Please. Okay, it's open. Debug mode is connected. Let's switch it off and switch it on back. Okay. Let's connect this device back. And please come on, please. Restart the stream, dude. Yeah, bro. Just restart the stream. Then no problem. But I need to chat. I guess I need to restart the laptop itself. Maybe it's the issue with the laptop itself. Okay, so I'll just quickly end and restart the stream by just restarting my laptop in 5 minutes. Sorry to those viewers who are watching right now, but yeah, I'll just restart the stream. Maybe the stream continues from where it ended. Not sure if I have restarted it back. Now I'm just trying to connect things. Sachin Chaudhary, last question is of bit. It was not of bit. It can just be done by like, although you can do the same thing by n trees, segment trees, also by simple sorting and stuff. So yeah, last question was by simple just arranging and sorting that stuff, same stuff. Let me just quickly resolve this thing and fingers crossed, please now we should be able to go live. I mean, we are live, but just it is restarting. If it is not done, I'm dead. I'm legit down dead. But meanwhile, let me quickly connect the Chrome tab. At least everything has gone dead. Damn. Cool. Now yeah, it is done. Let's connect that back. God, oh God, please restart that. Let's see if it doesn't restart. It doesn't. It didn't restart. If it didn't restart, no worries. We can actually go via the simple format of just writing down the same stuff or just drawing in our OneNote itself. We can just draw in OneNote and just let you know, guys, that how it is being done. If it syncs, then it's nice. If it doesn't, then also no worries. I'll just try and do that same stuff. Let me quickly share OneNote. Group window capture, and it's OneNote. Like really apologies. I didn't know that it won't connect. I had an idea that it should connect, but never knew that it won't connect at all. Oh damn, OneNote is also not connecting. What the? Okay, let's try. Shit. Okay, let's share the screen itself now. Display capture, and it's still now. Okay, I guess the screen is being displayed to you guys. If it is, then do let me know. Now we will just go through via the OneNote itself, because I guess that my tablet won't work. Okay, I need to place my camera above. Yeah, so sorry folks, I know the stream is dead now, but still I'll just try to go on back. So what we saw in this problem 2 was that we will just go on to problem array A and array B, and we'll just keep the count at every index and see, okay, for every element from 1 to 50, is it in both of them A and B right now or not? If it is, then I'll just say increase the count, else I'll just say okay, don't increase the count. So let me quickly go on to the next problem itself. So what it will say is that, okay, shall we have it, or shall we code it, or shall we just move on to the code? We can code it quickly. It's very easy. That firstly, what I will do is, I hope that you guys can see the screen itself. So what we can do, firstly, what we need to return is, we need to return the answer, which is for the entire array. Now, as I said, for every, which means for A and B, I need to make sure that number should be present in both A and B. So I can keep an a set, unordered set, map, or anything like that to just keep the, okay, is that number present or not in A or not. So here, as you can see, I just took another map to just keep the count at every place, and another map for B for just to give the count of every element, which means to just know, okay, is that element present so far or not. Now, what I can do is, or I have to do is, I will just go on to every of those element in A, which means I'll just go on at every index, and at that index, I need to make sure, okay, what is the count of common element in both of them, which means what element can be there? Element can be from, as you can see, from 1 to 50 only. So I can just go on up till, or I can also go on up till the size of this, because permutation is nothing but from 1 to n. N is nothing but the size itself. So I can just go on to the size of this particular, that, okay, the numbers possible can be 1, 2, 3 up till n. N is nothing but that size. Now I'll just check if that element J is present in both of my A and B so far. But before that, first let's increase the count of our both the elements, because ultimately I just need to make sure that that element should be there in both of them, array A and array B. So I'll just keep the count of both of them like this by just having that map to just keep, okay, is that element present or not. Now I'll just check, is that element J present in A? Yeah, good, but it should also be present in B. If it is the case, then I can increase my count, and it will just let me know, okay, up till this index I, how many elements were in both A and B, and ultimately I can just push back the same stuff in my answer, and ultimately I can return the answer as well. So that should be good. Let's quickly submit, and yeah, that's accepted. Now moving on to the next question. It was also pretty easy considering my OneNote is open and you guys are seeing that stuff. Not sure of what happened today. Everything planned went crashed, but still we will actually do what we have to do. Now what here it says is that firstly, oh, size is pretty big, that's what she said. No, firstly, maximum number of fish in a grid. So it is saying that I'll just increase the font. Oh, I'll just increase the font right here for you guys, and yeah, it just says you are having a 0 indexed 2D grid named as grid of size m cross n, where R, C represents, okay, if it's a land cell, so the value at that cell would be 0. If that is a water cell having a fish, then it would be more than 0, which means not 0. So the grid has values 0, it's a land cell, and a value not equal to 0, it's a water cell. Now what happen is a fisher can start in any water cell R, C, and he can start at any water cell, and he can do the following operation any number of times, which means catch all the fish at the cell or move to an adjacent cell, right? Hey, just a quick question to you guys, is it okay whatsoever is being shown to you guys? Like, I know my tablet, you can see right, sorry, you can see right here, it's not connecting. I tried a lot. Maybe I will just look out in this night after this, but I didn't want to quit the stream because of just this thing that I can't write on my whole tablet. The writing would be pretty bad via mouse, but yeah, please bear with me. I'll make sure that it don't happen next time, but apologies Pro Max from my side. But yeah, no worries. Just quickly see that we have to return the maximum number of fish that the fisherman can catch if he chooses his starting cell optimally, right? Now what he can do is he can choose a cell and he can pick the fish out of that cell and he can move to the adjacent cell, which means what fisherman has an option. He will just start from any cell, random cell. For sure, he will not start at land. That's pretty sure, right? And he will never move on land because fisherman lives in water, stays in water, works in water. So he will just, what he can do, okay, I'll just start from some water land. I will just grab 4 fishes. Cool. Now I can't go up, I can't go right, I can go down. Cool. I'll go down and grab this 1 fish also. Now I have grabbed 5 fishes. Can I go right? No. Can I go down? No. So in total, I have grabbed these 5 fishes in here. But is it the maximum fish I can grab? No. What if I start from 2? Then, oh, I grabbed 2 fishes. Now I can't move down. I can't move left. I can move right. Okay, I can move right. I'll grab 1 more fish. I grab 3 fishes. Now, number of fishes in total are 3. I can't go right. I can't go down. Ooh, good. Aryan, the answer is 3. It agrees. What you said? No worries. Let's look at more possible cases. What it can happen is, it can start from this 3. Then it can go right. Just it will go to 2 and grab 5 fishes. Now what will happen is, it will just grab these 5 fishes. Cool, no worries. But still the answer is 5. Is it maximum? Maybe, maybe not. Let's look at other cases. Which means lastly it will just can have, okay, I start from this 3. Then I can go on to next, because I am just a fisherman. It's my pond. I grabbed 1 fish and other one is also reachable for me. So I'll also reach that particular water and grab those 4 fishes. So yeah, that would be it. It will just grab 7 fishes. It is done. Now, what will happen, you will see is, in total, he could have grabbed 7 fishes, 3 fishes, 5 fishes, or 5 fishes. In total, if he choose this point, then he can grab 7 fishes. It is the maximum fish he can grab. Let's look at the next example. It is nothing but he will just grab 1 fish. He can't go right, down, because see, it is 4 directionally connected. If you have watched our bar graph series, just a quick request to the guys who are watching right now. I know I have XYZ my stream. I'll not say the name of F words, but if you guys are liking it, then please do the like button. Let's move on to 35 likes. Why I'm begging for likes? But yeah, still, it's smash it, spank it, do whatever you want to do. Just squeeze it, throw it. No, don't throw it. But yeah, what other option is, I can just start from this water cell right here. I can go up, down. No, I can't. So 1 fish I can catch from here. 1 fish I can catch from here. Indirectly, I am saying I can catch only 1 fish. That is the maximum number of fish I can catch. I return a 1. You saw what happened here. You just started from a water cell. I'll just erase all that stuff quickly so that I can just tell you again. So what I did here was, I started from a water cell and tried to reach to every water cell and tried to grab the fishes. I started from 1 water cell which has not been visited yet. Then I tried to go on to every water cell, and okay, saw what's happening. I started from 1 water cell, saw, okay, what's the number of fish I can grab? Started from 1 water cell, I can go, okay, what's the number of fish I can grab? You saw what's happening. It is 1 component. It is another component. I had this done, simple question by flood fill. Yeah, correct. That's simply a flood fill or simply a connected component algorithm that you just have to do simple. Okay, it's 1 component. You just go on to this particular component, find what is the sum of all the cells in that component. In the next component, you find what is the sum of all the cells in this component, and every time you just keep on updating. Okay, I just want the maximum sum. I want the maximum sum. So I will just say, okay, what's the sum of this component right here? What's the sum of this component right here? Component. Every component, I'll just grab the sum because it is entirely fishes I can grab. I'll just grab the sum. I'll just take the maximum every time. And ultimately, I can just return that maximum sum component. It is the exact same problem of finding the number of components in a matrix, just that rather than finding the number of components, I have to find the sum of every cell inside every component, and by that I have to just update that thing. So yeah, I guess that you guys got the problem. it's pretty simple that how we find the components. We just traverse on my entire graph. See, a matrix or a grid is nothing but kind of graph. So I just traverse on my entire graph. Traversal, as I have told in my BAP graph series also, that traversal we can do by BFS, DFS. Simply, when we can use both, we usually prefer to do a DFS because it's fast, and fast is right fast. You can just code it down faster. That's the reason. So we can just do a simple DFS and we would be good to go. So what we can do is we can just do a simple traversal, flood fill, you can call it, same thing. It's just that you can just you are filling that component. So what we can just do the same stuff, and we can just find the component sum, which means sum of all the cells in that component, and just keep on taking, okay, what's the maximum, what's the maximum, what's the maximum right now. Let's quickly go on to the code itself. It's pretty easy. What we can do is simply, we have this in, shall we code it or shall we just quickly go through it? Because it's actually very easy, like very standard code of our graph to find the components. The only change is grabbing this sum right here. That's the only stuff. So what we do here is that firstly, we just grab the N and M of our grid, and then I have that visited stuff that I can just simply visit every cell. I have to visit every cell exactly once. A traversal, a finding component, all that stuff is simple. We just have to traverse the same stuff. So we just make sure we traverse one stuff one through time. Like one stuff one at a time. That I just visit every cell exactly once. Now, maximum sum is nothing but, yeah, 4 question is just next right after this. We will have the 4th question. It's actually just coming up after this example, after this code explanation. Maximum sum, we'll just grab. Maximum sum is maximum sum of every component. Also, sum of every component we can grab. I'll just go on to every cell. Whatsoever cell is not visited so far, I will just find, okay, what is the sum of that component? If I start from this cell I comma j, what is the sum of that cell's component? I'll just grab that sum. My function of DFS will return that sum, and I can ultimately keep the maximum sum as, okay, what is the maximum sum so far, and the sum you have got for this component right here. How this function of DFS would work? It's simply as simple as how we used to do earlier. That I'll just grab my N and M. I will just check, is that cell I am going to I comma j, is that a valid cell? Is that inside my matrix? Yes. If it is not, I have to return a 0. But it's not the only condition. What if I have reached a cell which is actually a land? My 0 is a land, so I can't go to land. Okay. What if I reach to a cell that is already visited? I can't visit that cell. So any of these cases, when you reach out of the bounds of that matrix, when you reach at the land cell, or when you have reached a cell which is already visited, just return 0, because you don't have to visit that. It's not required as such, no? Now, I have to find the sum of that component, but the sum of that component starts from that cell itself, which means the sum will start from the cell itself, and it will just say, okay, what is the sum of your DFS? What is the sum of your DFS? What is the sum of your DFS? And what is the sum of your DFS? But I will add my sum also, because I am also included in my DFS. So I'll just do the same thing. I'll just grab the sum of my grid, and also the sum from my right cell, which means I plus 1 comma j, my left cell, sorry, my bottom cell, which is I plus 1 comma j, my up cell, which is I minus 1 comma j, my right cell, which is I comma j minus 1, my left cell, which is I comma j minus 1. It is I comma j plus 1. I will just grab this sum from all of them, and I will just return that sum. And also make sure to mark your cell as visited, because you don't have to visit that again and again. And thus, by just traversing our whole grid once, we can find what is the maximum number of fish, the fisherman can reap or catch or do that stuff. I hope that you guys liked it, and let's move on to the last lovely question of this contest. It was actually good. Moving on to the white R1 note. Let's quickly zoom bit. If you have not liked so far, please smash that like button. It will be super helpful. Let's see. So basically, yeah, it is working in OneNote if I'm just writing down by internet sync, but it's pretty late sync, but no worries, we can actually go through it via this mouse itself, although it's not that good. I would have grabbed my one tap, that thing, but no worries. You are having an integer array called as nums containing the distinct numbers. Now what you can do is you can perform the following operations until the array is empty. Cool, no worries. What is the operation like? If the first element has the smallest value, first element, then remove it. Otherwise, put the first element at the end of the array. I will just have the array with me. Let's take the example 3, 4, minus 1, right? You have the array with you. 3, is this the smallest element? No, right? Cool, no worries. Just put it at the last. 4, is the smallest element? No, put it at the last. Operations right now completed are 2. Minus 1, smallest element. Yeah, cool, remove it. Done, 3 operations. 3, smallest right now, because it is all gone. Clause is gone, no worries. 3, smallest so far. Yeah, okay, cool, remove that. 4, smallest so far. Yep, remove that. 5 operations and it's done. Let's move on to the next one. 1, 2, 4 and 3. 1, smallest number. Remove that. Cool, 1 operation done. 2, smallest number. Remove that. Cool, 2 operations done. 4, smallest number. Move back. 4, gone, 1 operation done. 4 is gone there at the end. 1 operation to move that at the end. Cool. 3, is it minimum? Just remove that. 4, is it minimum? Just remove that. Cool, 5 operations done. 5 is my answer, as you can see. Next, 1, 2, 3. 1, minimum element. Remove that. 1 operation done. 2, minimum element. Remove that. 1 operation done. 3, minimum element. 1 operation done. Number of operations are 3. One thing for sure you can note right now, that if you have n elements in any order whatsoever, you saw what's happening here, you saw what's happening here, you saw what is happening down. But no matter what, if you have those n elements with you, for sure, answer is at least 10. You can agree with me on that part, because if the answer was 1, 2, 3, which was already sorted, but to remove those from your array itself, just a quick thing before you guys have not liked it, then please smash that like button. We have to reach 40 likes. If you guys liking it, although I know that we are not using our tablet to actually write, I don't know what's happened to this, I'll figure out in the night, but meanwhile we have to solve the problem, and it's what is main focus of ours is. Now, what I was saying was, no matter what n elements are, in the best case is when all the elements are arranged in the increasing order, because I will just remove 1, I'll remove 2, I'll remove 3, I don't have to shift any of the element in the end. But in that case also, my minimum answer will for sure be n, because removing n elements will take n steps for sure. Cool, I just know one thing now for sure. Okay, my minimum answer is for sure n, which means n I will take to actually remove that element, not shifting. Shifting is a different step which I will add, but removing is n. Removing will take n steps, but shifting steps I will just add later. Cool, no worries. I just know one thing, removing steps are actually just n. Now comes the shifting steps. For that I have taken a specific example, from which I actually get to know how it can be done. Now I don't have my tablet, so I will just draw it down for you guys. minus 9, minus 15, minus 19, 5, 4, and minus 14. Right. Now, at first glance, when we look at, and for sure, the indexes are 0, 1, 2, 3, and 4. You saying, okay, Aryan, why you mark the indexes? It's just for convenience. Okay. That my main aim, see, my main aim is when I should look at the constraints, it is 1e5, which means I can't do something like O of n square or something. I have to do something of O of n or O of n log n, that's it. Which means, and I'm mostly concerned about what? Smallest value, right? Because ultimately I have to remove that smallest value. So it's the reason. One thing which maybe it is useful, maybe not. Maybe it is useful, maybe not. But one thing which can click my mind is, I'm concerned about the smallest value. So let's focus on the smallest value itself. I just try to bring my smallest value at the start. That is what I want right now, right? Cool. I want smallest value should come at the start. But for that, I should know what is the smallest value right now, right? So I'll just say, okay, smallest value is minus 19. Suppose minus 19 is done. Next smallest value is minus 15. Right? Let's say minus 15 is also done. So I'm just right now saying, okay, what is the smallest value right now, which I have to analyze. Initially, I will analyze for minus 19 because it is the smallest value. Next, I will analyze for minus 15. Next, for minus 14. Next, for 4. And lastly, I will analyze for 5. Now, to actually say, hey, I want a location because ultimately it is my original array, right? But I am analyzing in the sorted manner because ultimately I am concerned about bring the smallest element at the start. Oh, smallest element start. What is smallest element like? Oh, Aryan has showed you, okay, it is a smallest element. But smallest element, I have to actually go back to my main array also because I need to know, okay, it has to come to start only, right? So for that stuff, let me remove that. It can be done, right? Yep. So for that stuff, what we can do is, I will just keep, okay, 19, its index was 1, minus 15, its index was 0, minus 14, its index is 4, 4, its index is 3, its index is 2. It is just to actually go on that smallest element. I have not yet discussed the algorithm with you. It is just, okay, to actually reach that smallest element right now in just O of 1. Okay, cool. Now, I just know very easily, currently my smallest element is minus 19. Aryan, can I remove it? No, for sure no. It is not in the start. Oh, not in the start. Which means I have to bring it to the start. Nice. So what I can do is, I will just quickly move it down because now I'm concerned because now you will for sure know at every step what is the next minimum element you need to visualize for. Cool. When we analyze for minus 19, we checked. It is the minimum element. No. Which means minus 15 has to go from here. It has to come. Right? Cool. No worries. So minus 15 went where it can only go in the last for sure. So minus 15 came here. Now my minus 19 would be at the front itself for sure, right? Firstly, let me quickly copy this stuff, else I won't be able to replicate that same stuff with you guys. Right? Oh, I'll just do it later only. But what we saw is minus 15 is gone now. And it is at here. With this help, our minus 19 is at the start itself. Oh, that is good. But do you see one thing? It is on the start, and we also always consider our answer, which means our final number of steps, it was n. What was this n? N was to actually remove that. I never counted for shifting part. Because of this minus 19, my minus 15 has to shift. So I will have to count for this minus 15, the number of shifts. Because of minus 19, I did. But for now, minus 19 was done. It came at the start itself. It came at the start itself. And from as soon as the element is at the start itself, to remove that element, we have already counted to actually remove that element. In our answer already has n steps. As I've told before, to actually remove that, we have n steps. To shift, we have to count. But we don't have to count because I have shifted minus 15, not 19, right? That's the reason. I will count shifts for minus 15. Now, cool. Minus 19 has gone out, right? What will happen now? Let's see. Now, the new thing which will happen is, let me quickly grab this thing again. Oh, this whole thing again, I guess. This whole thing. I'm really sorry. I have to do this via this tablet, via this OneNote, because our tablet is not working. Really apologies for that. But yeah, now minus 19 was gone. Now came the chance of minus 15. See what will happen for this. You saw what happened to actually move this particular. If you had this minus 19, you just brought this minus 15 at the top. Your position of minus 15 was less. Now, next smaller element was minus 15. See, minus 19 is done right now. I reach on to minus 15. Now, how minus 15 would know that was it impacted because of any earlier element or not? Mark my words. How minus 15 would know that was it impacted by any earlier element or not? Which means it might be possible that what if minus 15 was already after minus 19? It was not impacted at all. But I could see minus 15 was before minus 19 and it was impacted because it was before. So I will just say, okay, my current position of minus 19, which means if I just go back and see, okay, my current position, it is my last position. My last position of whatsoever element I have, and it is my current position. Right, it is my current position. Let's name it as current index or something of this element. Current index or like this. As you can see, my current index, if it is less than my last position, current index 0, less than my last position, which means my minus 15 was for sure impacted because of this minus 19. Impacted, it was impacted. Yes. But you saw what will happen. As we saw, put the first element at the end of the array, which means this minus 15 will have to go. When your current position, current index, you are standing at minus 15, your current index is actually less than the last position, which was 1. Last position was 1 and it's 0. So it was impacted because of our last position. So we actually have to add the steps count, which means shifting steps will be added in this particular count. Now, how many will be added? If its index is 1, which is right here, it is n. Now, if I have in total n elements, 1, 2, 3, 4, 5, n is 5. I have this one which was shifted. Now, because of this shifting right here, it just went on to our last position. One step right here, but for this minus 15 to actually go back to this location right here, one step to actually move back, but it actually also have to go back these 3 steps to actually shift back again to the first location. In total, what we saw, 1 step to actually go back and next 3 steps to come forward. In total, I have n step. N is my whole number of things. 1 was already, it had occurred. नहीं समझ में आया, अरे we had just started explaining that. I'll just recap that same stuff. Just get to know the gist of what we are just grabbing right now. Cool. What earlier happened was I was at 15, minus 15. Now I had to go move that minus 15 to the last location. Now from that last location, I have to again bring back that to the first location. Now first location is when minus 19 has gone. So moving this to the last location, 1 step. Bringing back to the first location, first location, considering number of elements left right now are n minus 2, because n ultimately, see, ultimately I had n elements, one element gone, 19 gone, remaining element n minus 1, so all the elements are minus 15, minus 5, 4 and minus 14. These are 4 elements. Remaining elements are 4. One step to actually move this minus 15 to end. Now minus 15 is one of the elements. Now these, in total the elements are n minus 1. So the remaining elements are nothing but n minus 2, which means n minus 1 minus 1. So 1 plus n minus 2 are the total number of steps which actually this element has to take. It is nothing but n minus 1. Why n minus 1? 1 was because one element has already gone. That's the reason. Ultimately, I just say my one element, I have just cluttered this a lot, but I'm just saying that my one element was gone. That's the reason. We just grabbed out one element was gone. That's the reason. It is indexing based 0. I equal to 1, I equal to 2, I equal to 3 and so on and so forth. So one element was gone. That is the reason I just removed that particular index from that. So I can just say, okay, my element which is right now, I have to number of steps which I have to increase. See, I just told you, when we have to add the number of shift steps in my count, the condition is when your current index is actually less than the last position. If it is the case, you have to increase the count, which means the number of shifting required. Number of shifting required are nothing but n minus I. Why I? Firstly, why n minus I? N minus I is nothing but one step to actually shift that particular to last, and now again to actually shift this back to the first location. Considering I have skipped these locations, if you are actually at the second position, ultimately you are moving from the smallest to largest, which means here you are moving from I equal to 0, I equal to 1, I equal to 2, I equal to 3 and I equal to 4. Right? So you are standing right here, which means one element has done, one element has gone. So I don't have to count that one element in this skip range. So I have to skip only one element. That is the reason I will just do n minus I. I is nothing but here 1. So only one element is skipped and rest, which means minus 19 is not counted for my skipping range. I just did a one step to actually reach at the end, and n minus I minus 1 steps to actually skip those n minus I elements. I is nothing but 1 because one element has gone. So n minus I elements I skipped from right here to right here, and one element. So that's the reason n minus I minus 1, n minus I minus 1, because it is one element which actually went from here to here. It is one step to skip these. It is n minus I minus 1 steps. So one step right here, n minus I minus 1 steps to skip those n minus I elements, n minus I minus 1 elements. So ultimately n minus I minus 1 plus 1 for move to last, n minus I minus 1 for to skip those n minus I minus 1 elements. Ultimately it is n minus I. That is the reason when I have the condition when my current index is less than my last position, which means it was 1, it was 0, then I will just add this count. Cool. Now let's see what will happen next. As we go on next, let's quickly modify this back again. Shall we not? We had what we had. Cool. Let's do it here only. I don't think we can modify this. What will happen now? Now ultimately our minus 14 is like it looks like this. Let me go back again. So we started off with what was the array itself. This was this was the array itself. I know it is taking a lot of time because we are actually not using our tablet. If it had been a tablet, the life would have been such easier. But still, if you guys are understanding that same part, then please do the like button. Let's hope for 55 likes. I don't know what I'm doing. Yeah. So basically what happened was minus 15 was gone. minus 19 was gone, right? Now came the chance of minus 14. You got what happened? What will happen? Because of this, these will change, will shift. Ultimately, I have to bring this to the location, first location. But for that, it has to go at the end, right? It will just go at the end. That is what will happen right now. So basically this minus 14, as we saw earlier in starting, minus 19, we just had, okay, it will just come at the start. But for that, minus 15 has to shift. So shifting steps are for minus 15. Thus, shifting steps are right here will not be for minus 14. Minus 14 is not shifting. Shifting will be these elements. Okay, cool. These elements will get shifted. We had earlier this particular thing. So this will come in the start. What happened now? You looked, this will come one step, which actually it's for coming, not it's not coming itself. When all these are being shifted, it automatically comes in. That is the reason why it is coming back. But what will happen right now is, any chat, did you guys get firstly how we are actually having those number of steps to move from the first location to the last location, and from the last location to the first location? And when are we considering that step? When our index, next bigger element index is actually lesser than the smaller element index. Cool, no worries. Let's move on. That if we have the next element as minus 14, so these will actually go back. Cool. Minus 14 will come in the front, which is actually one step which we actually have considered before only. But when अरे समझ ही नहीं आ रहा, no worries. Have you just watched the previous part? If you just grabbed it, then if you just go on from the starting itself, why it is important and why the indexing, all that stuff is important. Firstly, I'll just go through that completely, and after that, if it still is not done, then we can actually look at it. But right now, if you just see, समझाया सही है, but question ही ऐसा है, जल्दी नहीं समझ आएगा. Correct. That's also case because you have to actually deep dive on how it is being done. But yeah, I am making sure that how these steps are being performed. But firstly, we looked at why, if we have n elements, no matter what, to actually remove that element, we need n steps. So removing part, I have counted. Now shifting part is actually, I'm counting more. In my answer variable, I am adding my shifting parts more. So for this minus 15, I added my shifting part, which is 1 to actually, ultimately, in my answer, I had what? In my answer, I had initially 5 for removing 5 elements. Now for this minus 15, I had shifting part. Shifting part was, in total, it was n minus I, which means removing, I just forgot key, one element is removed. So I just imagine, okay, now I have n minus, I have 4 steps, which means 1 step to actually go back to the end and 3 steps to actually skip those 3 elements of the end. It is ultimately 4, right? Which is nothing but remove, considering I have removed 1 element, which was 5 minus 1. Right now, cool. Now these minus 15 and minus 19 were gone. Now to actually look at these 2 cases of my 5 and 4, minus 14, for this minus 14 to actually remove, it should be at the first, which means these 2 should have been removed, should have been shifted back. Cool. So the next element would be shifted back, but it will just be removed. So I will, and for removing part, I have already counted for these n steps. Now it is done. It is removed, which means my 5 and 4 are actually gone at the end. 5 and 4 are at the end now. Now, if you had remembered one thing, you shifted 4. But what if you don't know? Because see, the next incoming element according to R is minus 14 is done. minus 14 is done. Next incoming element was 4. How you know that shifting of 4 was done or not? Maybe 4 would have been after this stuff, after minus 14, right? So how you know that shifting of 4 was done? As I told you, by the indexing. Index of 4 is less than the index of minus 14, which was the last element. That is the reason. For sure, 4 has to be shifted. That's the reason what we did. We shifted our 4 to the end. You remembered what happened? You shifted your 4 to the end, right? That is the reason. Why? Because how I knew right now, because I am trading on only these numbers, right? How I know that 4 was actually before minus 14 or after minus 14? By its index. Index is 3. Its index was 4. Its current index is 3. Last index was 4. Which means bigger element was before the smaller element. For sure, bigger element would have been shifted. I will count the shifting now, which means I will just try. Shall we erase this part? Larger eraser, and that is should be done. Cool. Now, what will happen is, let's move back. This 4 has to be shifted. 4. Aryan, how will the 4 shift? 4 knows that it has to shift back. Then it has. Okay, if it has shifted back like this, it has to again come back. Because shifting, now I'm not considering 5 right now. Don't imagine 5 right now. Just imagine 4 right now. What happened by this 4 is, your 4 is standing right here. It has to go back. One step, going back. Next step is coming to the first location, which means skipping how many elements? Skipping one element. How you know, Aryan, only one element is skipped? I know, because I have completed n minus 3 elements already. N minus 3 elements are done. And one element, as I'm considering right now only. I'm considering 4 only right now. So my n minus 3 elements are done. N minus 3 elements are done. So for sure. And also 4 is like never counted. So minus 1 for that also. N minus 4 elements never counted, because n minus 3 already done. And minus 1 for 4 itself, because 4 is itself an element. Number of elements to skip, n minus 4. Right? One element to actually move to the end. For I'm counting only for 4. So in total it is n minus 3. You saw what happened? It is actually nothing but, it just says n minus 3 is nothing but, it just says n minus 3 elements have been done so far. As simple as that. It's counting one element for itself for shifting, and 3 elements. Okay, 3 elements are already done. It has already gone. Don't consider them at all. Right? That's the reason I'll just say, okay. Now the shifting steps for this 4 is nothing but n minus I. I is this index right here for this 4. The shifting steps for this 4 is n minus I. N is nothing but 5. I is nothing but a 3. Shifting steps is 2. As you can see also, 4 will go here, and after that it will go from 5. It will just skip and it will come to the start. And removing that, we have already counted in our steps. So ultimately, we added a 2 for our 4 to actually go. Now our 4 is also gone. Now comes the interesting part. Now is remaining only 5. Will you say, Aryan, 5 is already at the start itself. So for sure, just remove that. And for removing, you have already counted in your array right here. So just add a 0. I will say no. You're forgetting one thing. You remember one thing, what? You're forgetting. When you are shifting minus 14, sorry, my color of this pen is very, very, very bad. I'll just change the color itself. When you are shifting this minus, I'll just erase that. Yeah. When you are shifting this minus 14, you remembered what happened. You also shifted 4, you also shifted 5. Right? Which means both of them shifted. 5 shifted and then 4 came right here, which means for this 4 right here, 4 was never shifted. Your 5 was shifted after it. And we considered our 4 was shifted. So basically the effort of 5 I counted in 4, and the effort of 5 now I'm counting, okay, to get to the end of minus 14. The effort of 5 is being counted right here. That is the reason. Now, how we can say, Aryan, the effort of 5 I'm counting because of minus 14? See, its index is 2. Its index is 3. It is smaller. It is larger. 5 is smaller. It means it will go at it will shift. It needs some shifting steps. But it needs a shifting steps for this minus 14 only, right? And this was already considered for here. That is the reason. This 5 will have those shifting steps for us if we consider its index is 2 right here. Its index, which means the last index, was 3. It has the smaller value. Last value was 4, which was smaller. Index was higher. My index, I'm standing at 5. My index is smaller. I am behind my 4. My 4 is after me, which means I had to go beyond 4, which means I have to add some skipping steps to actually go beyond 4. And those skipping steps are not actually for 4. That's actually for minus 14. Because ultimately, you are just skipping that minus 14. And because ultimately you saw what happened. Your 4 was actually also skipping your 5. It is just that 5 is skipping back to the last location, and your minus 4 is skipping to the first location. And those steps are being counted. How to count and when to count? We saw. When our index of the current element, because the current element is right now 5, because it's the last element right now, and the last index was actually 3. 2 is less than 3. 2 is the smaller element. 3 is the larger element. Sorry. 2 is the larger element. 3 is the smaller element. That is the reason we need to count the skipping steps to actually move that 5 after 4. Because 5 needs to go after 4. And thus our 4 will actually come at this first step. That is how you will skip these things. So initially you saw that in last one step for our 5 skipping, which means n minus nothing but I is nothing but, as you will see, if we just sort the same stuff, I, where is I gone? I is nothing but 4. So it is nothing but I minus, it is 5 minus 4. That's the reason I will just get one step for skipping. In total, 5 steps to remove, 4 steps to shift my minus 15, 2 steps to shift my 4, 1 step to shift my 5. That is how I will just get entire total number of steps. Here you will see it is 5 plus 4, 9 plus 1, 10 plus 2, 12. It is 12 number of steps to actually go on to this example. I hope that you guys liked it. Before moving on to this code explanation, got TLE? Yeah, for sure. If you just apply the brute force thing, you will get TLE. That's the reason it has the beauty of this question that yeah, correct. But 4 को shift करने के लिए 5 को shift करना पड़ेगा पहले. Correct, that is correct. But we will shift 5 only when the chance of 5 will come. 5 will say, okay, how many steps I have to shift. 4 will say how many steps I had to shift in total. So everyone is considering number of steps they have to shift for all of them, for all other of them which are remaining right now. That's it. So before moving on to the problem code, the code is pretty simple as we saw in the explanation itself. Just that condition, if our index, as we saw, let me go back, if the current index, if it is less than the last index, if it is less than the last index, I will just add the count of shifts which is required. Before moving on, please reach that 60 target of likes just three more, just three more. Yeah, and the code is exactly very simple. And as you know, I made sure I have to evaluate the smallest element in the start itself. So I have to sort it. But you also remember, I have to also make sure that I actually need the location of my smallest element in my actual array itself. If I sort the array, how will I actually know what was the actual location? So firstly, what I will do is I will map the actual location of my smallest element, which means every element location is mapped right here. If you just clearly go and see, then 19 was at index 1, minus 15 at index 0, minus 14 at index 4, 4 at index 3, and 5 at index 2. So I actually need to evaluate my elements at original array. So it's the reason I took a mapping of every of my element to its index. Let's see. I will just quickly show you both of them, code also and also the what we saw in OneNote, that how it is being integrated to each other. See, firstly, I have this called as actual index, which will actually map every element to its index, and we for sure know that every element is unique right here. If we say containing distinct numbers, so it is for sure that every element right here is unique. Cool, no worries. Every element was unique. So I'll just grab the actual index of every element, which means it will just go on the entire array itself. And also, oh goddamn, light went again. Lovely. What's happening? So what it will happen is it will just mark for every element what is the actual index it is having. Actual index will say, if I just pass in the number itself, it will just return me the actual index it was having. Now, as I said, I am only concerned about the smallest element right now. For sure, right? So what we will do is we can just sort it down. And why sorting will not affect us? Because I have already stored what was the actual index for every element. So if in future I need the actual index of every element, I can get to know that for sure in the later steps. Now comes the interesting part. I will just go on to my every of those in my sorted array. I will just go on from the starting. Okay, initially the smallest element is minus 19. Now think for minus 19. Next element is minus 15. Now think for minus 15. So I will just start from my smallest element to the largest element. It's the reason I just sorted my nums, because I want to think for the smallest to the largest element. Cool. I just go on from the smallest element. Now, already I have counted. You will see, already I have counted in my answer the n answers. As I said, answer will be for sure at least n, which means removing those numbers. Shifting I will count later. As you can see, shifting I am counting later. And you also saw the condition was the condition for shifting was that the current index, change the color, the current index, which is 0, if it is less than the last index which we have seen, it is 1. If the current index is less than the last index, for sure I have to shift that minus 15. Now number of shifting steps required are number of remaining elements, which means when minus 19 is gone, which means one element has gone. At the index of this minus 15, it tells I am the second number. I equal to 1 tells I am the second number. Or I can also infer I equal to 1 as before me I had one number. And before me, which means I am moving from small to large. Which means I am moving from small to large. Which means I have already evaluated the smaller numbers so far. So one element has been evaluated already. You don't have to consider that. In total, you have to consider what? Remaining elements. Which means shifting these locations and moving this to the last locations. Like last location. So ultimately the steps needed would be nothing but n minus I. I is nothing but 1, saying one element has already evaluated, already gone. Don't consider that one element, because consider only the remaining elements. That is the reason it is n minus I steps needed for this minus 15 right here. And that's all. And as we know that for every element, I was just thinking of my last index for sure, right? So just make sure that you update your last index with the current index so that in the next iteration, you can actually know, okay, what was the last index of me? And ultimately, I can just return the answer. With this, I can actually add the number of shifts required for every of the element, because the removing part was already done in the answer. Shifting part was actually now seen in this problem. I hope that you guys got it. If you guys have got it, then please can we reach 65 likes? And if you guys have any questions so far, I will be super happy to answer those. If you guys have, I'll just read the comments again. I didn't read it, but really apologies. I'm really sorry that it didn't work. If it would have worked, I swear the explanation would have been much more clean. See, although I tried to explain via this, but as you can see, the number of crosses, circles, overlappings was way too much. While if it would have been this tablet, it would have been super awesome. I don't know why I didn't connect. I'm really sorry for that. Really sorry. But you guys showed love. You are just awesome. Like, just awesome. I don't know how, but yeah. So if you guys have any questions, just to let me know. I tried to add the index difference between smallest element and the front element. I tried to add the index difference between the smallest element and the front element. Yeah, that's also. What were the different approaches thought for solving Q4? So basically the Q4, initially I thought was what's happening is you are having these 4 elements. I'll just quickly go back again. If any other questions for any other people, just write them down. I just say one more standard approach which comes in people's mind by solving this kind of problem is that oh damn god, lovely, again the light has gone. My life is fucked up now. Whew. Cool, no worries at all. We will just see how we can do it. Shall we not? Is the voice audible? Yep, it's again back. Sorry. Considering the video is looking fine. Yeah, it is. Now, the standard approach which comes in people's mind is that if I have something like 3, 4, minus 1. Now, one thing for sure is if I have to bring this to the first location, right? It means that I have to evaluate these two. For sure, I will just keep the count as 1, 1. Now, I will just can have this count. Okay, when I'm shifting my minus 1, I can have this count. Count of a range sum, it can be by a segment trees or Fenwick trees, right? Now, when I am at 3, I just say, okay, what is the count required so far? It is nothing but 0. Here at this step for 4, when I evaluated 3, I just update the value cell as 0. Here, as it is done, as minus 1. See, minus 1, I started off. I just tried to add, okay, what is the count so far? By range sum, it is nothing but 0. So it is nothing but 2. Now, I will just update that sum to 0. Next, when I am landing on 3, I'll just add the count after, like, before it. Like, nothing is there, right? So count is 0. But I'll also modify its count because it is done. When 4 comes, I'll just ask for, hey, what is the count for you? Before you, it will say 0 because 3 has already been done. So it will just say 0. But ultimately, I will just add the 0. So you saw what happened. 3 steps to actually remove those elements, which is n equal to 3. To shift, I shifted minus 1, which is 2. For these 3 and 4 shiftings, I added a 0, 0. And you saw what happened. Simultaneously, I am updating my every element of my Fenwick tree, which means updating the index and finding the range sum. By this, you can also solve it. But if you just try to solve the basic Fenwick tree, it will not happen because of this example right here I showed you below, which means this minus 19 minus, sorry, it was not the example was minus 15 minus 19 5. If I just write that down, minus 15 minus 19 and 5. When you will try to evaluate minus 19, what you will do is you will put that as 0, right? Now ultimately your answer will be for sure 3. You can for sure modify Fun to actually solve this problem, but I'm just showing, okay, what all multiple approaches can come in your mind while solving it. For this, I updated the value as 0. Initially, everything is 1. Initially, everything is 1. I'll just remove that. Yeah. Initially, in my Fun tree, every node is 1. As I went on to minus 19, I just asked minus 19, hey, what is the number of steps required for you to shift? Oh, god damn. Ads will run shortly for some viewers. I'll just skip the ads. I don't want anyone to get them. But I don't know why it's again done. No worries, you guys. I don't know if you're audible or not. If it's audible or not. If it's audible, yeah, it is audible. So really apologies. But what we can do is that if you guys have done, you can just leave the stream. It's done. Before leaving, if you guys liking it, then do hit the like button. But for the folks, Anirban, yeah, or Abhishek, yeah, Abhishek has asked, so I'm just replying to that problem, that for this it will just say, okay, what is the range sum? Before it is nothing but let me quickly see if it is visible. Yeah, for the range sum it is nothing but 1. So one step to actually add for minus 19 to actually reach the first location. Then it will ask minus 15. It's the next bigger element. It will ask minus 15. What's the step for you? It will say 0. It will ask 5, and it is updating 0 also. It will ask 5. What is the steps required for you? It will say 0. But you will see the steps required will be for minus 15 also. It will actually reach to the start and then go back to the reach to the end, go back to the start. So you have to modify this Fun tree also to actually reach to your solution. But although implementing the Fun tree also, it can be a bit tricky for a few folks. So that stuff which I showed you above is much simpler and easy. But yeah, it's actually hard to visualize at first, especially in the contest, that how I can actually, I know, okay, number of steps to actually start, number of steps to actually shift, I need to require, okay, shifting steps are required. How? If I elements are already done, shifting steps are n minus I. And how to know I have to shift or not? When I'm actually impacting previous element which was actually smaller than me but after me. That's the reason how I will do that. So yeah, that was all from my side. I hope that you guys liked it. We have to go to sleep because in the morning we have to wake up at 5:30 and bring out the tomorrow's problem, because tomorrow live is also coming. Tomorrow's contest is also there. The day is gonna be hectic, but I also need to make sure that it just connects. Why it was not connecting? God damn. But yeah, I loved your like. I loved your love. What is this? But yeah, that's all from me. I hope that you guys liked it. Before going, if you can just make that likes to 70, that would be awesome. If you cannot, then no worries. That would be it. So yeah. Bro, I am in the end of second year. Can I start applying off-campus intern? How do I know that openings are for 2025 grads at the rate? So basically, yeah, you can for sure start. I'll just switch back for some gupshup times. We can have it a bit small, gupshup. But yeah. The problem was I saw the first two questions, 37 minutes. Is it good preparing for OAs? Let's just for the MS Darshan. Bye bye. Good night. Bye bye. Anirban. Nice having you on the stream. Just yeah, MS Darshan's questions. For sure, you should start applying off-campus interns. For sure. The best option is just quickly go and look at the career portals for any of those companies, whichever you like. Just have if you have not watched that list of companies, if you have not watched that project video, so in that we have actually shown all the list of companies. You can just go on and look at the career portals. Okay, what they have opened and what openings they have. Intern positions right now open will always be for sure for third year, but if you are in second year, then HackerRank, there was one company, I forgot the name. Like, these are some of them which actually give the internship in second year also. So it would be good that you actually go and look at those particular companies. HackerRank is one of them. Like, if not, then CodeChef also provides internship. You can also have internship can be done in multiple fields, not necessarily programming, but any field of experience you add on would be good. But for sure, just maybe asking for referrals, but it's hard to actually go on and see, okay, what all companies are actually coming in for these second year folks. But what's the harm of applying? Let's say if the internship is happening and if you think you're capable enough, you have projects, you have good problem solving skills, for sure apply. Maybe you can beat the third year folk. That could be. I couldn't find the which grad are they hiring. Yeah, that is hard because they just open that interns. Most interns they keep from the third year itself. Not sure that, like, usually they don't put in for grads or the pass out year for the interns. But yeah, it's just mostly looking at LinkedIn, going on to the career pages of multiple websites. If you don't find it, apply. Best is apply. I'll just add UPS. So basically, I'll just say, I don't know. I know that you guys can't hear me, but still, it's best to just go and apply, and that would be it. Worst to worst case, they will not revert back. Still, you will have the entire 1 year. Because see, if you just think, okay, if I just apply now, and what if they don't come back and all that stuff. Still, you have the entire 1 year. That lock-in period will actually get removed in that 1 year period. So that will be for sure okay for you guys. While on the other hand, the next stuff was, let me change. I will for sure buy a UPS now. No matter what, I'm buying a UPS. If you guys are still watching it, please make it as 70. Good night, bro. Missed the stream. No worries, you can watch it again. I solved the first 3 questions in 37 minutes. 37 minutes for those first 3 questions are a bit. Is it good preparing for OAs? See, although the level was like this, first 3 questions at this level, last question was at this level. So usually the question in OAs are at these levels, like this, right, at this level. So it is not the right contest to judge that if you were able to solve this in 37 minutes, then is it good rating or not? Because every problem was brute force or standard. The first 2 ones were brute force. The third problem was standard basic problem, which everyone would have implemented. So it's not the right contest to actually judge that were you able to actually be good for OAs or not. But still, 37 minutes indicates that maybe your brute force implementation would be a bit slow. Or your third problem, like, can you have the bifurcation of every problem, that how many minutes you took on every problem? Maybe I can give a better idea on what you can improve on, like which part you can improve on. Because see, if you did the first one in 37 minutes, it can be either of 3 options. Maybe your typing speed would be a bit low, or usually it's never the case. The third can be maybe you got some error while implementing it. Maybe to implement that brute force itself, you were taking some time. The last one, or it can be indicated with that one only, that for that third problem, which required that standard approach, of just modification of the standard approach, maybe you were not much familiar, or you had to look back at your components code or back at your notes to actually write the code for that. So 3, 13, 36. Okay, 3, 13, 13, 36. So 3, 13, 13, 10 minutes. 10 minutes for question 2 is a bit long. That could have been completed in 5 minutes, considering it was basic brute force. Considering 36 minutes for the next, which means around 23 minutes for the next problem, although it could be reduced to half because it was a very standard problem. So whenever the standard part comes in, it is assumed for many folks that we can do that same stuff very fast. As you will see, maybe your rank, I'm not sure, it would be around 5k or 6k. Like I was not sure like how much the rank would affect, but for sure one thing is that our speed can be increased for the standard problems at least, while when the thinking part comes in, and for sure for the brute force also, because usually we always should assume that one thing, brute force can for sure come. I know that I'm not visible still. I will just for sure buy UPS no matter what. I'm gonna buy it tomorrow. That's it. I will just go and look at the offline stores online. I'm gonna buy it UPS. I'm done with this shit. Yeah, the next question was middle. I tried to solve the 4 in middle rank is 4207. Yep, correct. Yeah, correct. Yeah, I know that stuff. I've been bound of this shit now. I'm done with this shit. I'm done. Yeah, there was for MS Darshan, it was 524, 11, 45 and 40, 16. Considering that's AP, arithmetic progression. So question 2 solved fast. Question 1, 5 minutes. That's thoda sa more for the question 1. Considering you are in a second year, that's nice. I have my solving time above, bro. Yeah. That is what I'm looking at. So 524, that is actually, it can be like, it can be brought to 3, but 524 is actually still nice, because Shivam 520 like 3 was actually like, it's very standard basic. So it's just, even if you have implemented the brute force one, not the maths which I showed you, that n plus 1 by 2 formula which you take for n element sum, still it would have been done in 2-3 minutes. But yeah, that's fine. Question 2, 11 minutes in total. I consider that it's accumulative. So question 2 you took 6 minutes. That's great. Question 3, 40 minutes. Sorry, in total it would be around 29 minutes or something. That would also, yeah, we have a Telegram channel by Aryan _Mittal, something like that. For the folks watching, can we please go at 75 likes? That would be great. And you can also solve the questions. Manish, we have our Telegram channel. You can just go and look at the description of any of our things, live streams, any of our channels, any of our videos, no matter what, or at our main homepage of our channel also. We have for sure our channel. MS Darshan, I was just saying, for the last problem it was 29 minutes. That's also fine, considering that's a standard problem. It could have been better, but yeah, in starting, considering you folks are starting out, that's actually a good one. So make sure, see, programming is actually thing that is and for sure require consistency. if you be consistent, if you just actually solve the problems, understand the logic, go on to those standard stuffs. Because see, whenever I teach you, I show you intuition also, which can be applied to multiple problems. That's the reason. You just have to learn every problem like it's the problem I understood right now. With this, whenever you, because see, it can happen a lot of times that you just saw one problem, maybe 1.5 months later, you saw another problem. Same like that. There's a high chance you won't be able to solve it if you're saying it for the first time. But if you repeat this process again and again, maybe you saw this problem again, let's say 4th time, now you will be able to solve it. So thinking that, okay, I saw this problem one time and now I'm not able to solve it, it's not the case. We have to just solve it. It's a high chance that in 2nd or even in 3rd try, even seeing the kind of same problem, we would take time. But as the process repeats, it just gets onto our nerves, and now we just have this, okay, it can be done like this, it can be done like this, it can be done like this. Now, okay, it's done. It is how it is done. Will you start Code Forces contest because we could not solve more than one problem in the whole contest? I thought of starting Code Forces contest discussion, but the entire day just goes in like anything. I just thought, okay, I'll just give contest, probably have discussions. But in the morning also, I have just made the graph series lecture, but I came in the mid of the contest. I had a 5-minute nap. That's how much in the middle of the contest I'm saying. That's how much, because I was not able to think. I thought, okay, I need to have a nap to actually like rejuvenate my stuffs so that I can actually start thinking stuff. Because like yesterday, we slept at around 1:30ish or 2. I came back. I went on for some movie, yeah, Evil Dead Rise on Friday. So came back around 2 a.m. Then wake up around 5 a.m. to actually make the morning contest. And then again, I went back for clothes shopping today. So I could not actually do that stuff. But I just will try that as soon as I don't want to commit any new stuff right now, but as we get on the track, we'll actually try to solve more and more problems, more and more contests also, because solving contest won't be that hard, but maybe we just need to get to the track at least. If you guys are watching, I could solve 3rd question in less time, but graph काफी time से किया नहीं और एक argument को by reference pass नहीं किया, count सही नहीं आ रहा था. That's okay. It happens a lot that we don't solve a particular stuff. Maybe in this problem also, last problem I was trying with and victories, I couldn't solve it. If you guys are watching to 24, 22 folks, those folks, can we please reach to 80 likes? That would be awesome. If still that was considered, if you guys like, see, it happens if you just see a problem of try, let's say in January, now in April, you just look at the problem again, there's a high chance you won't be able to look at that. But shit. I forgot to end the stream. देखो ये जिंदा है behind scenes. Damn. Like I just saw your comments. See, what happened was it just ended, and damn, you guys are still here. I just said it. The stream ended, and damn. So yeah, continuing to what you guys were saying, I just ended. Like, kitna sexy hai na, bhai. Fuck. What was visible? Damn, bro. Yeah. The few messages. आ गया. Bye, boys. Sad. Cool. That was all. I hope that you guys liked it. I don't know what was happening. Oh damn, stuff was right here. You guys saw multiple stuffs behind scenes, but cool, no worries. Let's end the stream right here. Anyway, the one question was from Shivam. No, you don't need to do segment trees for online assessments unless it's online assessment of a few companies, like 1 or 2, like Coordination. That's it. Not even DShaw or Google. Like, no one asks segment trees. I've never seen asking. If they ask segment trees question, maybe if they ask, then maybe it is a reason. It can be something of which can be implemented by Fenwick trees also. So Fenwick trees is very easy in comparison to segment trees, but segment trees, there's a very high chance they won't ask. So yeah, that was all. Try के बाद तो बताओ भैया. Try का क्या बताना है? We were waiting for the try क्या? I didn't get what try was. How come try came in picture? Try. But yeah, that was all. Before leaving, those guys, if those guys were still watching, I don't know what blunders or all happened. I will for sure buy a UPS next time that this kind of stuff will not happen. It can't be bought in tomorrow's stream because like we also have a stream tomorrow, right? Tomorrow for the tomorrow's contest, and it's already won. We need to sleep. We need to wake up tomorrow for tomorrow's contest and give that contest and give the stream. But before leaving, if you guys are still watching, then please go and have that 85 like count, and we would be happy to leave. Those viewers, if they have not, if I guess for sure they would have, but cool. लास्ट क्वेश्चन भैया जी, एक क्वेश्चन करवा देना. इंट्यूट के ओए में आया था. इट वाज काइंड रिलेटेड टू ट्रीज. कॉइंस थीव्स मैक्सिमम निकालना था. इट वाज डीपी ऑन ट्रीज शायद. हार्ड प्रॉब्लम ऑफ इंट्यूट. हाँ, इंट्यूट देयर यूजुअली आस्क दैट medium to hard problem. DP on trees, considering it's a DP on trees, it's not hard considering it's actually gone to many sub problems. Depends upon what kind of DP on trees they are asking. DP on trees varies from very easy to actually very hard. It entirely depends upon how the DFS is working. But yeah, you can just share that in a Telegram group and we would be good to look at it. Those viewers can reach 85, but still not. If not, then we guys are ending the stream. Thank you so much for watching, for having that patience. I swear मेरी फट के हाथ मार गई थी when like the tablet was not working, electricity was going on and off, internet was going, everything was just horrible today. I don't know why and what, but yeah, that's all. See you guys in the next video. Goodbye, take care, bye bye.